Hello viewers, welcome to UN College Digital class. In today's class, I am going to discuss about Dijkstra algorithm in design and analysis of algorithm class. In the previous classes of algorithm, I have discussed about tree, graph, Prim's algorithm, Kruskal algorithm, all those. In this class, I will discuss about Dijkstra algorithm, which is very interesting one and which is used to find out the shortest path in a graph. Let's start. Dijkstra algorithm is used to find out the shortest path from a starting node to a target node in case of weightage graph. We know that there are various type of graph, weightage graph, non-weightage graph, directed graph, undirected graph, lots of different types. Okay, Dijkstra algorithm is particularly implemented in case of weightage graph to find out the shortest path from a particular node to the target node or to the destination. Okay, the algorithm creates a tree of shortest path from the starting vertex, the source, to all other points in the graph. Dijkstra algorithm is published in 1959 and named after its creator, Dutch computer scientist Dijkstra, and can be applied in case of weightage graph. It cannot be applied in case of non-weightage graph. Okay, the graph can either be directed or undirected, no problem. One stipulation to using the algorithm is that the graph needs to have non-negative weight on every edge. This is one restriction, that it must consist of all positive weightage value. It cannot contain any non-negative weight. Okay, now I am going to discuss about the basic of Dijkstra algorithm. Basics of Dijkstra algorithm. The first point is Dijkstra's algorithm basically start at the node that we will choose as the source node, and it analyze the graph to find out the shortest path between that node and all other nodes in the graph. Okay, if in the question it will be given a particular node as the source node, then we will use that node as source node. But if that is not given, then it depends on you. You will select one node as the source node. This is the first point. This is the first basic point of Dijkstra algorithm. The second point is, once the algorithm has found the shortest path between the source node and another node, that node is marked as visited and added to the path. Okay, and the next point is that the process continues until all the nodes in the graph have been added to the path. This way we have a path that connects the source node to all other nodes following the shortest path possible to reach each node according to Dijkstra. Okay, it is a greedy algorithm that solves the single source shortest path problem for a directed graph G equal to V, E. V represent all the vertices, E represent all the edges with non-negative edge weight, that is WUV greater than 0 for each edge. Okay, now I am going to discuss about the algorithm. In the algorithm, the first step is create a set, that is shortest path tree set, which I have represented as SPT set. You may use any name, no problem. That keeps track of the vertices included in the shortest path tree. Actually, this is our output. Here, the minimum distance from source is calculated and finalized, and then that is placed in this tree set. Initially this set is empty. This is the first step. Then the second step is assign a distance value to all vertices in the input graph. Initialize all distance values as infinite. Assign distance value as 0 for the source vertex so that it is fixed first. Okay, first of all, we will create a tree set which will be our output set, and at the second step we will assign all vertices, initialize all distance value as infinity, and the distance value for the source vertex will be initialized as 0, and we will choose this one. At the third step, now what we will do, at the third step obviously one loop will be continued till the tree set, which is our output set, include all vertices. Inside the loop, pick a vertex u which is not there in the tree set and has minimum distance value. Then at the next step, it is also inside the while loop. Include u to the tree set. Okay. Then the next step of while loop is update distance values of all adjacent vertices of u. To update the distance values, iterate through all adjacent vertices for every adjacent vertices v if sum of distance value of u and weight of as u minus v is less than the distance value of v, then update the distance value of v. In this way the algorithm will work, but we will understand it by using one example. But before writing the example, before explaining the example, let me write down the Dijkstra algorithm which will be helpful for the examination purpose. Okay. The Dijkstra algorithm will take G, W and S. Here G represent your graph and S represent your the set which is the final output, and W represent weight. Okay. Then inside the algorithm, the first step is initialize single source GS. Then S, your set is initially empty. Then we will take one vertex from the graph and we will place the vertex in the set. Actually, we will choose that vertex. You can choose the vertex randomly, or you may choose the vertex which will be given as the starting vertex. Then we will continue till all the vertices will be included by using a while loop. Inside the while, we will extract the minimum is a minimum vertex which is having minimum weight. Okay. Then we will add the vertex in the result set, that is S. In this way, we will continue the loop till all the vertices are added into the set. In this way, the Dijkstra algorithm will continue. Now I am going to give one example so that you will be clear. Okay. Suppose here I have represented one graph. The graph consists of A, B, C, D, E, 5 vertices, and you can see that number of edges are there. Okay. In this graph, suppose let me use C as the starting vertex and I have initialized all the vertices because as now I am at C, all other vertices distance I have initialized as infinity, and gradually I will select one by one on the basis of distance or on the basis of weight given. Okay. Initially we have selected C. When we have selected C, yes, this one. When we have selected C, actually what we will do, we will select all the vertices which are connected to C directly. Okay, those are A, B and D. Those are directly connected. Now let me check the weight. Which one is the minimum weight? And here one is having, this edge is having minimum weight. So at the next step, what we will do, we will select the C to A. And here one more thing is that here I need to mark C as visited, and at the next step I will select A. Here you can see that I have selected A. Okay, this one. Already we have selected C, already we have visited C, and we have marked C with a green tick so that we can understand that that is visited. Then now we are at A, and similarly we will check all the adjacent vertices. Here the adjacent vertices of A is AB, this one, and AC, this one, and as C is already visited, so it will be discarded. And here we are having one weight, that is 3. The distance from A to B is 3, but also we are having the distance from C to D previously, and as this distance is smaller than this distance, so we will select this one, CD path or CDS. Okay, and now the graph will be looked like this. Here you can see that we have visited C and A. Previously already I have told that whenever we have completed the visit of any vertex, then that will be marked with a green symbol. Here you can see that C is marked with green tick and A is marked also with green tick, and in this step we have selected D as the source, and now we will check the adjacent vertices and try to find out the minimum weight. Here you can see that the adjacent vertices of D are C, B and E. But as C is already visited, so we are having B and E, and previously from A to B also we are having, A to B is having 3 weight, D to E is having 7 weight, and D to B is having 5 weight. As among 3 this one is smaller, so we will select A to B in this step. Okay, and now our graph will be look like this. Here you can see that C is marked with green symbol, A is marked with green symbol, D is marked with green symbol, as it means that all the vertices are visited. Now we are at this point. Okay, and we are having, again we will do the same process. We will try to find out the minimum is the weight, and here it is connected. B is connected with A, B is connected with C, B is connected with D, and also B is connected with E. But as A, C, D all are visited and only one node is left, that is E, and B to E is having 1 weight and D to E is having 7. Okay, and for that reason we will select this one, B to E, and at the next step we will have the graph look like this. It means that we have visited at this step A, C, D, B, and now the next one is B, E will be visited, and this graph, this is the final output. Again also I have used the final output representation of this particular problem so that you can understand. Initially we have selected C, then we are going to select A, then at the next step we have selected C to D. All these selections are based on the weight. Okay, and at the next step we have selected B, and at the next step, or it is the final step, we have selected E. In this way we have find out the shortest path. Okay, and this is a tree like structure. This is the explanation about Dijkstra algorithm. Now here again I have used another example of Dijkstra algorithm, so you will be clear on the concept. Suppose in this graph I have used 0 as the starting vertex. Okay, here you can see that 0, 1, 2, 3, 4, 5, 6 number of vertices are there and number of edges are there. Let me first select 0. So when I have selected 0, the adjacent vertices are 1 and the next one is 2, and I will check 2 and 6, the two weight which are given of the edges, and as 2 is lesser in comparison to 6, so I will select this one. Okay, I will select 0 to 1. After reaching at 1, I will check all the adjacent vertices of 1, and here 1 is connected with 3 and 1 is connected with 0. Okay, And as 0 is already selected, let me use a mark here so that we can understand that this is visited. Actually this is visited, 0 is visited. And now we are at 1, and we will select either 1 to 3, that is consist of 5, or 0 to 2, that is consist of 6. As 5 is smaller, so we will select 1 to 3. And now this vertex is visited. Which one? 1 is visited. Previously we have visited 0, and the next step we have visited 1. Now we are at 3. After reaching at 3, again we will try to find out all the adjacent vertices to find out the minimum one. And the connection are 3 to 2, 3 to 5, 3 to 4. And here we are trying to find out the minimum one. 3 to 5 is 15. 3 to 2 is 8. 0 to 2 is 6. Also we are having 0 to 2 value previously, that's why. And 3 to 4 is 10, and as 6 is smaller, so we will select this one. Okay, in this way we will continue. Now here again I need to use a blue tick so that you can understand this one is visited. Which one? 3 is visited. And again we are at 2. And after reaching at 2, we will check all the adjacent vertices 0, 3 which are visited. So we will shift to another point, that is 3, and from 3 we can visit 5. The weight is 15. 3 to 4, the weight is 10. As it is having the smaller weight, so we will select this one 4, and we will visit 3 to this point. Okay, and from at this point what I need to do, I will just give a tick mark at 2 so that we can understand that 2 is already visited. Now we are at 4, and after reaching at 4, what we will do, again we will try to find out all the adjacent vertices, that is 6. 4 to 6 is 2. 4 to 5 is 6. Okay, and as 2 is smaller, so we will use 4 to 6, and now we are here, and let me give a tick mark at the 4, and we are at 6. After reaching at 6, again we will check the adjacent vertices which is having the minimum weight. 6 to 5 is 6, and 4 to 5 is 6. So here, yes, here one interesting concept, that sometimes what happen, you may get the output, or you may get the values of a number of different edges which are same. At that time we will select any one, no problem. Either you will select 4 to 5 or 6 to 5. Here let me select 6 to 5, and now the connection is in this way. Let me use a tick mark here, and as there is no more vertices are there, so 5 is the ending point. Actually let me use draw the tree so that you can understand clearly. Let me draw the tree by using the green. Yes, we have selected 0, then from 0 we are here, then from again we need to select 1 to 3, then after that we have selected 0 to 2, then after that we have selected 0 to 4, then after that we have selected 0 to 6, then from 6 to 5. Okay, in this way here you can see that it is a graph, it is a tree, it is not a graph. It is the outcome according to the Dijkstra algorithm. I hope you have got a clear concept regarding Dijkstra algorithm. Now let me discuss some disadvantages of Dijkstra algorithm. Those are, first one, it does a blind search. So obviously it wastes a lot of time while processing. The second disadvantage is it cannot handle negative edge. Okay, And the next one is it leads to the acyclic graph and most often cannot obtain the right shortest path. And the last one is we need to keep track of vertices that have been visited. Apart from all the disadvantages, still the Dijkstra algorithm is very interesting one and also popularly used by the programmer. In this class, I have discussed about Dijkstra algorithm along with example. If you have any doubt, then please write to me in the comment box so that I can clear your doubt. Thank you so much for watching. Have a great time.